All right, we're live there after the countdown. Welcome, Lucas. Welcome everybody in. I'm just gonna hand off to you for a second. I'll intro you, and then you can talk about yourself, and then I'll start asking you some questions. So, who are you, Lucas? What do you got for us today?
Sounds good. Yeah, happy to join on here, Mike. I'm Lucas, one of the co-founders and the CEO here at Loft Labs, and one of the people that got vCluster started a couple of years ago. And it's so exciting to see so many vClusters out there and so many people trying it out, putting it in different places. And GPUs is coming up quite a bit. So I'm really excited for this conversation.
All right, so we're talking about GPUs and stuff today. So also, I think one of our new use cases that we're kind of tackling is bare metal. But why bare metal now? Like, what's changed in the last couple of months, even, I guess, to make bare metal a thing?
Yeah, I mean, there's a couple of trends going on, really like big macro trends, right? One is obviously, VMware's acquisition by Broadcom, and people are looking for alternatives there. Them checking out the prices, right? That definitely drives people to reconsider choices. I think the other trend is the whole explosion of AI workloads, LLMs, training workloads, right? And the GPUs that are needed for this, and the need to run as close to bare metal performance and the hardware performance you can squeeze out of these GPUs as you can, because that hardware is just so much more expensive than what we've been doing with CPUs over the past decade or two.
So why everybody moved to VMs to run it so they can do a little bit better segmentation of users? Like what now has made it so that you can actually do this in a way that's a little bit more secure, right? I think that's one of the biggest concerns is security and separating people so that they're not able to actually use the same machine, kind of bare metal.
Yeah. It's definitely interesting, when your workloads are already containerized, right? It's a very valid question. I posted about this on LinkedIn the other day. Asked people, your applications are containerized. Why do you need VMs in your Kubernetes clusters? And the answer is really people need to form these little, 5-10 node clusters in order to segregate their tenants, right? And when you think of the origins of Kubernetes, inspired by Borg, right? I think it's supposed to be this large-scale distributed system. There isn't supposed to be like 5,000 Borgs for 5,000, squads of 10 developers at Google, right? Like that's not the idea. The idea is really to have like one large-scale distributed system that owns pretty much all of your nodes, right? And you give it, workloads to run, and it figures out where to run them most efficiently and when to run them. And the scheduler in Kubernetes really is the magic thing here that got a lot of attention in the early days. And you go back to the Kubernetes blog posts from the earlier days, and you're like, oh, the scheduler can handle 200 nodes now, 500 nodes now, 5,000 nodes at some point. And a lot of attention was focusing on how big can Kubernetes get, because the more nodes it can hold, the more your machines become cattle instead of pets. But the reality today is we have a lot of like pet clusters. So each one of these clusters consists of 3 or 5 VMs. So you have pet clusters instead of pet machines. That's the reality in most companies. And I think we're at a maturity stage where a lot of companies are wondering, does that make sense? Did we fulfill the original promise of Kubernetes here? And if not, what can we do about it? I think that's the macro trend really that we're seeing.
So what's your message to somebody that's like, all right, I'm moving off VMware. I'm looking at my options. I'm going to do VMs again, but all my stuff's in containers, right? Like maybe I'm going to move to OpenStack or something like that. Why can I just avoid OpenStack? So I just like you said, you go to one big Kubernetes cluster, right? Like instead of moving to other VMs. Like what's your message to them? Like if they're exploring ideas of what they should do next?
Yeah, generally, let me start with the disappointing piece. You're not going to ever get rid of all of your VMs, probably for the foreseeable future. There's probably a lot of mainframe workloads still running at large banks in the United States, because it's always the layer on top, and it's certain workloads move over as you're refactoring and as you're building new services, right? But you're probably always going to carry around some of that legacy, right? If your applications are not containerized, there's no clear paths. Like you have these heavy Java EE applications that just want a whole machine to themselves, potentially. It's really hard to refactor them. Maybe it doesn't even make sense from a business perspective to put a lot of attention into refactoring this and containerizing this. So probably entirely getting rid of an OpenStack or vSphere is probably not an option. But for your Kubernetes estate and for the forward-looking pieces of your infrastructure, I think there's a very clear path towards, okay, my applications run in containers. Can't we spin up a Kubernetes cluster with bare metal machines and then have Kubernetes kind of form this cluster around it, schedule workloads on this cluster, and have the scheduler really do its job? And the question really is, when you have these big nodes, these heavy nodes that you don't split up in VMs, how do you segregate things at the node level? And there's a couple of technologies out there that have been around for a few years who attempt to isolate containers more strongly. Cutter containers comes to mind, which is micro VMs again. So you're unfortunately back on the VM track, despite trying to look for alternatives. At least you're talking about like very lightweight Kubernetes native type VMs here. But then you're also looking at other solutions. User namespaces is a great technology. And you can look at gvisor. They do second filtering to make containers more secure. And obviously, we launched vNode, just recently at KubeCon EU in London. And with vNode, we're really combining the benefits of user namespaces and forming a sandbox environment out of a container that runs in a user namespace, and then launch your workload inside of that sandbox. And at the same time, we do second filtering. We emulate your procfs and your sysfs, right? So we're really trying to harden this environment as much as possible without going as far as spinning up a separate VM and having a completely separate kernel and drivers, etc., right? So going just as far with all the technologies that are available in container native land without jumping over to full-blown virtualization.
It's pretty telling too that there's companies out there that just operate to migrate from VMware to something else, and you have to pay them to be able to do all of that. So it's difficult to go from VMware to something else. So might as well look at other options that are out there too. Like, why get locked into something if you can go to a vanilla Kubernetes install and do something like this instead, right? Like, that's everyone's trying to sell you the VMware to something, right? OpenStack, something else, but it's still going to be difficult and take time.
Yeah, KubeVirt is a big one as well. I'm a big fan of the project, but admittedly, KubeVirt compared to VMware had like 25 years to build a pretty awesome technology and an amazing stack and a lot of automations around. And these virtual machines and in VMware, they're like hyper optimized, right? It's probably as good as it can be. They're squeezing out every little bit of performance and reducing the overhead as much as possible. You can't expect the same level of automation and tooling and optimization from a project like KubeVirt, right? That is much more community driven versus something that's been built over 25 years by a company that had a $60 billion market cap, right? Like that's really, really tough to make that comparison. I do think though then that in a few years from now, technologies like KubeVirt will mature to the stage that makes them much more comparable. But today, there's probably a lot of things you have to live with in terms of adjusting your expectation if you're going to make that change. And we see a lot of benefits in managing virtual machines the Kubernetes way, as you can do it with the KubeVirt operator. So we built that integration directly in vCluster because certain workloads, again, they're not containerized. You're still going to need a VM, but that doesn't mean you can't manage that VM the Kubernetes way. You can provision it through a CRD, right? And you can access it through the regular flow of how you would do lifecycle management for deployment in Kubernetes. That's obviously a really nice benefit.
So as KubeVirt gets better, it's going to get more complicated too, right? Let's go ahead and hop into the one of the overviews that you've been working on, and maybe you can give us some information about this, right? So we've been thinking about this a lot, right? Thinking about how do we do bare metal Kubernetes with vCluster on top for a bunch of different options, multi-tenancy and all that too. But we're gonna do a couple diagrams. So we're gonna hop into this diagram. Lucas, you want to tell us what's going on here? Like, what are we looking at?
That's a pretty busy stack here, right? So let's start from the bottom, right? So generally, what we see a lot of companies trying to do, they have nodes with GPUs attached, right? So they have like, I don't know, 40 DGX systems or something like that, right? Plug them into their private data center. And then, they're trying to form Kubernetes clusters out of them. The question now is, how do I separate tenants on these nodes? And I'm talking predominantly at first now for, non-GPU cloud providers doing this. Like, literally, hey, I'm a big Fortune 500 company. I purchased a bunch of DGX systems from NVIDIA. I put them in my data centers. How do I make the most out of these H100s that I now have running there, right? Utilization is obviously something you want to optimize. You want to drive up utilization as much as you can. And, the question is, how do I form clusters, right? If I could do, a cluster here, and then I have another tenant and they get a separate cluster over here, right? Like this would be one approach. But now you're thinking about, okay, how do I allocate these? Because it's not like you have 100 of these or 200 of these, right? Generally, a lot of these companies, they may have like 20, right? Or maybe they just have 10. So it's really hard to form clusters out of that, because if you have, 10 nodes, how many clusters can you form? Well, you can do 10 one-node clusters, right? Or you can do 5 two-node clusters, something like that. But the really inefficient thing that happens is when you're actually thinking about the scheduler. Because let's say you were to form a 2-node cluster and you were to hand out that cluster to a tenant. What if they're not deploying workloads right then? But another tenant may need these, GPUs. In the meantime, like how do you orchestrate that? It's a really challenging problem. A solution can be to create one large cluster that has all of your nodes and control over all of your GPUs, and then the scheduler can now be the effective handler of all of these different requests, right? So let's say you have like 50 different tenants and you have 10 nodes, and the scheduler can orchestrate, okay, how do I slice these GPUs? Who is going to run where and when, right? And obviously, there's very, very optimized schedulers. Run AI has their own scheduler. Volcano has is a scheduler that you can use specifically for these situations. And the more nodes you can give it, the more efficient it can do its work, and ultimately consider your entire estate of GPUs. Classically, the problem though is, how do tenants launch these workloads now? Because you may want to give them a separate namespace, but there's certain limitations to what you can do in a namespace, right? And then you have problems like their containers, how they're isolated on that node if you're actually running things on the same node. All of these problems emerge when you're just creating one giant Kubernetes cluster. And our approach is really, you'd run vNode on each one of your nodes. It runs as a daemon set that gets deployed to each one of your nodes. And then you can run vCluster, and jumping to the very top layer here, you can run vCluster at the very top and hand out that virtual cluster to each tenant. So they feel like they have a full-blown cluster to themselves, but they're actually just in a virtual cluster. And all of their workloads end up in a virtual node on the actual node. So there's an additional layer of hardening around them.
Awesome. And so what's the stack on top of it? Like, what am I adding here on top, right? Like, about all these storage options, all these networking options, all this ingress and network and observability, right? Like, how does vCluster help me with that? Like, how does that tie into like vNode and that kind of stuff? Does vNode give me options for more things or less things, or?
Yeah, that's another good question. So the question really is, how do you split things up that need to run in every Kubernetes cluster? So some of your operators have a very global scale. So think of something like NVIDIA GPU operator that needs to run in your cluster, but it's very close to the hardware, right? So does that need to run in each one of your virtual clusters? Probably not, right? It should run at the host cluster level, right? We typically differentiate between the virtual cluster and the host cluster. So the host cluster is really the cluster you're forming down here, versus this is your virtual cluster for each individual tenant, right? Running in a namespace on top of this host cluster here. And the NVIDIA GPU operator is something you would deploy to this host cluster, and that would generally be managed more by your IT team rather than by your individual tenants, right? Same thing probably for storage and networking. You don't want tenants typically to run their own CNI, right? You would install something like Cilium, right? The same probably counts for things like service mesh. You want to maybe share an Istio in your underlying cluster. You may even want to share observability. That may be something your tenants could roll on their own, but potentially is something you offer as a platform team to your tenants internally. Or you want to have a mix and match, right? Like for some tenants, they may want to run their own. Others may want to rely on what you can share, as a managed service for your tenants.
So there's probably people that are doing this on-prem that are thinking about this, and then there's also going to be like providers that are doing this and stuff too. I think we've had, I don't know if we want to touch on stuff that we looked at previously where we kind of helped someone else with something like this. I don't know if we can talk about that previous use. Talk about previous use cases. Like what does vNode bring to the table now that maybe was different than like a year ago? If someone looked into this previously and they're like, oh, well, I want a little bit more security, right? Like you said, it breaks stuff up and everything. But what does that mean to like an end user? Like, does that mean I can't escape out and I can't get to the base cluster anymore? Like,
yeah. So your tenants typically get a kubeconfig that points at this vCluster's API server, right? Yep. So they don't actually ever talk to the real cluster. They talk to this pod that's exposed via, ingress or load balancer, right? And when you're interacting with this virtual cluster has a separate state. So it can be a separate etcd cluster. It can be embedded etcd, which is one of our features. It runs a lightweight etcd inside the vCluster pod. But it can also be a SQLite if this vCluster is relatively ephemeral, right? And it doesn't have a lot of watchers and CRDs and requests. Then a SQLite may be totally fine running in a persistent volume, right? There's different grades of how reliant and scalable that vCluster can be. It can be super lightweight and cost efficient, and it can be more heavyweight if you're saying, hey, it needs a completely separate etcd for the vCluster. But the state of this vCluster is entirely separate. So when I deploy, I run, kubectl apply, and I provide a deployment YAML, right? That deployment exists only in the virtual cluster. It doesn't exist in the underlying host cluster. But typically the pods, they get synced down to the host cluster. So it would be like giving your tenant just permission to create pods. You were to give them a namespace and they can do only one object, and that is the pod. Right? So very, very limited attack vector. But there's still things on the pod level that you probably typically want to deny. Things like privileged containers and certain network capabilities. One of the things that vNode does, it essentially creates this sandbox around your pod. That means a container gets launched, and then that container runs in a user namespace, and inside that container, we launch your actual container. And that's a way for us to, filter your syscalls, make sure your the vNodes, the virtual nodes, containers, users run in a user namespace, right? So you can literally run a privileged container inside the virtual node, and you don't actually have any privileged access to the underlying real physical node, right? That's one of the beautiful things about vNode. So the combination is really powerful.
Yeah. We start seeing questions like, have y'all done testing on, vCluster at scale? And then they started asking about like SQLite. Like the SQLite might be a little bit of a bottleneck. And we're like, well, what are you doing? Right? Like we had customers and potential customers started asking us questions like, hey, this isn't scaling the way we wanted it to, but they were using SQLite. So like when you say the different use cases and stuff, you can use embedded etcd or external database and stuff like that. Your first deployment of vCluster, you're going to use SQLite, and then you're going to mess with it. Then you're going to give people access to it. Well, if you're giving 100 people access to it, you don't want SQLite anymore. You move to like an etcd option, right? So that's where you have embedded etcd up here, right? We have multiple options for it, right? But it takes different planning to get that set up. I was just kind of adding on.
We can maybe jump to the docs here real quick.
Yeah.
So if you're going into the vCluster YAML, which is the Helm values ultimately to deploy a virtual cluster with, in that vCluster YAML, in that type file here, you can see all the different options. One of them is control plane. That's how really your vCluster is set up. And under control plane, you see backing store. So for backing store, you can choose etcd options, or you can use database. And by default, we have an embedded database, which is literally that's SQLite. So this is your default, right? It's SQLite in a persistent volume typically. Then one option you can do when you hit the scalability limits of this default setting, you could obviously spin up an external database and say, okay, I'm going to move things out to a MySQL or Postgres database and just hook that up. But what you could also do is you could switch over to etcd from SQL based. You could switch over to etcd. And that's what a lot of things, what is very intuitive to a lot of folks, because they're used to Kubernetes running in etcd. So you can deploy an etcd with the Helm values here. It's just going to deploy a stateful set with an etcd in here. You can obviously deploy a separate etcd and just make that a dependency and hook it into your vCluster via other config options. But then there's also the embedded etcd, which runs alongside the vCluster container. And that's pretty neat because you can literally get a HA vCluster plus an HA etcd with the same container. So you're literally deploying a vCluster and you have a single part with replica number 1. You want to make it HA, set the replica number to 3. Boom. You got an HA vCluster plus an HA embedded etcd backing it up. And yeah, there's a whole bunch of war stories around this because sometimes people don't realize it. And you've heard them, Mike, right? But people hit us up and say, "Hey, we spun up vCluster and we put it in production, and our managed service is running in there. And one of our biggest customers has issues because we have too many, watchers on these Kubernetes CRDs, and our controller is, is getting to its limits, right? Literally, you're seeing it with your biggest customer first, right? And you have that approach. So it's quite painful when you get to that point. And I'm always surprised how far people get with like, hey, let me just put this in production and roll it out to like 500 customers and see how it goes without ever talking to these guys, right? And that's the beauty of open source. It should be possible, but we obviously don't hope that anybody has a fire drill. Yeah, just at KubeCon, one of the biggest insurance companies in the world, like we met them and someone was saying we run 1,000 virtual clusters internally. And I was like, oh, wow, that's a lot of virtual clusters. And I asked them, how do you do the backing store for these? Because this is very critical to how you're running internally. And they were like, oh, we just spun up 1,000 etcd clusters. And I was like, holy moly, that's a lot of etcd clusters. Someone at that company probably has a lot of sleepless nights, like, maintaining these etcd clusters. But that's essentially the solutions that we're working on with this, hooking up an external MySQL or Postgres, which is great. You can, if you're in AWS, you can just hook up RDS. And AWS takes a lot of that maintenance and management effort away from you. Or you can go with embedded etcd, which is, software managed etcd running directly by vCluster.
And then if you're just giving a developer a virtual cluster to just mess around on, SQLite. If you're just doing a preview environment or something like that, SQLite, because you don't need all that overhead. Like it's not really running that many workloads or anything like that.
Yeah, awesome. Absolutely.
All right, do we want to? All right, yeah. If anyone has questions or anything too, like this is interactive. Ask us some questions. Let us know how you're doing, bare metal Kubernetes, or if you're thinking about moving over, or if you're moving from VMware to something else and you have like questions. Okay, here we go. We have a question. All right, from a GPU cloud provider point of view that wants to sell vCluster, how can you define GPU resource allocation quotas and GPU types that are bound to a virtual cluster?
Oh, that's an awesome topic. Yeah. So generally, Kubernetes is relatively weak at this point, not just vCluster, right? But Kubernetes API in general. So right now, you obviously in the virtual cluster, you can define resource quotas just like you can do in a regular Kubernetes namespace, right? We ultimately deploy a resource quota in the underlying namespace typically. And that is very limited though, as everybody probably knows if they have ever ran GPUs with Kubernetes, because, CPU 10, like if you were to say GPU 10, like what does that mean, right? Is that like a fraction of a GPU? What type of GPU is it, right? Like for CPUs, they're relatively commoditized, so the difference is pretty minor, I would say. But for GPUs, they're highly different, right? Like you can get GPUs that cost like 20K, and you can get GPUs that are much cheaper than that, right? I assume there's going to be much more expensive ones going forward, right? So there's a lot of change happening in terms of GPU hardware here, and the range is just pretty broad. But DRA is something that Kubernetes is pushing heavily at the latest KubeCon, dynamic resource allocation. And we are working on a DRA integration inside vCluster directly. And that means you'll be able to essentially make use directly of DRA inside your vCluster. I think that's going to unlock a lot of this going forward.
It's also a thing about to get started with, because you have like multiple versions of even accessing those GPUs, like time slicing, and then I think Kubernetes adopted like MIG. It's like, which one do you pick? And it depends on which GPU you have, right? So it's all kind of confusing, right? All right, cool. So do you want to, brainstorm on another diagram?
Yeah, we can
think about.
Yeah, we can jump over here. So I copied the 3 nodes we saw in this other picture over here. Because one thing I think is pretty interesting to think about, when you're building a GPU cloud, whether it is for internal, but also for GPU cloud providers to actually hand these, GPUs out to customers, the question is really, how, when I want to spin up a managed Kubernetes offering or a serverless Kubernetes offering, what am I handing out? And, for in our purposes, often, obviously, in a lot of these questions, the answer is, well, vCluster is the API that I do want to hand out. So the question is, how do I set it up, right? I can spin up let me do this here. I can create a Kubernetes cluster here.
So keep the questions coming too for anybody. Hopefully that answered your question about resource allocation. If you've got a follow-up, you can bring it.
Yeah, definitely subscribe to the product updates. You'll hear about when the DRA integration drops. That's going to be a big one. I think a lot of people are looking forward to that one. So let's say we have these. Oh, go ahead, Mike. What was that?
I'll post a link real quick too in the chat so they can follow the changelog and updates.
Oh yeah, be awesome. So let's say you form a Kubernetes cluster out of these 3 GPU-enabled nodes here. The question now is, okay, what do I hand out to my tenants? So we can obviously create a virtual cluster here. We create one. Let's turn that into regular strokes. So there we go. Call that vCluster. Let's call it vCluster 1 here. So this is one of my vClusters. This is a second vCluster. So your tenant, or your customer in this case, can now interact with their vCluster, and you have maybe a second customer who is talking to this vCluster. How do you split things up?
Maybe take a step back, and for users, like if you don't know what vCluster is, right? Like, why would I do a vCluster instead of just namespacing these things for people that may be new? I know we're dropping vCluster like everyone knows what it is. I don't know if there might be a couple people that are just kind of tuning in. They're like, what's a virtual cluster, right? Like,
yeah, that's a good question. So a virtual cluster is a Kubernetes control plane that runs inside a pod on top of another cluster. So technically, I would actually have to extend this because we have one cluster here, and that cluster has 3 nodes, and it has 2 namespaces. And in these namespaces, we run a pod for vCluster 1 and vCluster 2. So now I got a control plane. Your tenants now can talk to this control plane. The big benefit here is if you were to just give them a namespace, they would be very, very limited. Let's say you're a GPU cloud provider and you kind of want to build your own EKS. That's the requirement we see a lot, right? Folks say, we got these GPU nodes, we can give you GPU nodes. How do we build a managed Kubernetes offering out of this? Or some kind of serverless Kubernetes offering? The difference I would draw the line at serverless Kubernetes offering is more of a, I don't get control of dedicated nodes versus, EKS, generally you see the nodes are kind of yours, right? I know there's also, EKS like auto mode, which automatically creates nodes for you via Carpenter under the hood, right? But generally it's in your account, you own these nodes, they're dedicated to you. If you're going with EKS versus if you have ECS, you don't really have to worry about any kind of nodes, or Fargate, for example, right? And I know there's all kind of crossovers in AWS. You have EKS with Fargate as a backend and all these kind of craziness, right? But ultimately, you want to have as much of a vanilla Kubernetes cluster to your tenant with all the capabilities of Kubernetes, that's the API you want to hand out, right? Because your tenants, they may want to run their own operators, they may want to create their own CRDs, they want to create namespaces dynamically on their own and split things up. So handing them Kubernetes API is awesome. But if I were to create this Kubernetes API statically, I get a very static assignment of nodes, right? And this is usually what cloud providers do for the most expensive contracts they have, where they have a big customer. It's just like, hey, give me a 100 node GPU enabled cluster here. No problem, right? Like you can put the effort in to create a full-blown Kubernetes cluster with a dedicated control plane running on a CPU node, for example. But if you have a lot of tenants that consume, let's say 3 months with a 2-node cluster, are you going to put in that effort? The answer is often no. So if you want to be more like EKS, where someone can spin up a cluster within minutes and start consuming this cluster, then vCluster is a great solution because you can spin up a pod, you can hand out access to this pod, which acts as a regular Kubernetes API server, and they feel like they got a full-blown cluster, but they're actually just running inside a container. It's a containerized control plane. But it is a certified Kubernetes distro. That means that Kubernetes control plane you're talking to behaves just like EKS or GKE, right? It's a full-blown cluster with full-blown capabilities. Now the question is, how do I split things up on the node level, right? So one popular approach, or the default approach we've seen in vCluster is we have a so-called syncer, and that means your pods actually get scheduled in the, let's actually maybe draw this. So I'll put the names.
You're about to drop a big differentiation, right? Like what's the difference between this and VMs? There's no real hypervisor. You're still running, right? Like you're about to say it, running on the Kubernetes cluster itself. So that you don't lose, any performance that you might if you're using like virtual machines or going up a layer.
Yeah, that's true. Yeah, it's native container native performance. That's always the goal here, right? So let me take these and change them a little bit. So this is regular Kubernetes namespace, right? And my vCluster runs as a pod inside. And let's say I create a deployment here. So now I got a deployment in this vCluster. That deployment creates a pod, and that pod lives only in my virtual cluster. It's not down here. It has nothing to do with my underlying cluster, but somehow that pod needs to be scheduled and needs to start to run. So what we do typically with the vCluster is we copy this pod down here, and let's call this pod 1. And this one's pod 2. And with these two workloads, the regular Kubernetes scheduler now would take over and would schedule this pod somehow on one of my nodes. That's classically what happens. And whatever scheduler runs in this underlying cluster could be, could be Volcano, it could be Run AI, it can be pretty much any, or it can be the regular Kubernetes scheduler, right? Putting it on this node. So now you have multiple workloads running on the same node. That's where vNode comes in. So what vNode does, it essentially creates virtual nodes here on this physical node, right? So you'd have, I'm going to call this VN1, and this one is VN2. And we're going to make sure that our pods get scheduled in these virtual nodes, and they dynamically spin up. These are just containers, but they're sandbox containers. They're highly secure, right? So if my workload is in there, and I'm running in a user namespace, so my users are mapped to unprivileged users, even if I were to run a privileged workload. So this is step one. vNode comes in at this layer. But then we also see, if you really, so this is more like a serverless offering. This is traditionally how a vCluster would be deployed. Let's say you wanted to instead launch more of an EKS type approach. The way you would deploy vCluster then, let's take a third virtual cluster here, is, and maybe we'll copy the whole thing actually.
So I have a question about the vNode stuff too, though. So vNode could be one physical to many vNodes, or it could be one-to-one if you just want one customer there, right? Like what's the normal use case you see for it? Like one-to-many or one-to-one? Because you still don't want them escaping and getting access to the network.
That's true. Yeah. So we don't generally do much around the CNI. We just forward pretty much everything to the regular CNI that runs on your node. So if you have a non-eBPF CNI running on this node, it's going to be a problem to isolate traffic between these two containers that run, even if they're running inside a vNode, because we don't do anything around networking, right? We don't things around process space and emulating your file system, mapping with the username space, right? Like filtering syscalls, right? We can prevent certain things, doing things around sniffing other folks' network, but there are certain things we can't prevent. If you're using eBPF, like Cilium, for example, you're going to operate at a much lower level. So if you have network policies, you can actually segregate the network down here. But what's even more secure is what you just said, and that means I'm giving separate tenants a separate node entirely to themselves. So in this case, it also would make sense to run things in a vNode, because I may have, as a cloud provider, I may have instrumentation on that node, and I may want to harden and shield my own infra, my own setup against my tenants. But I don't at least need to shield tenants from each other, right? So one thing you can do in this process down here, you can enforce node selectors. And what a node selector will help you with is, you can, in this vCluster, in these two vClusters, because the node is shared and you have more of a serverless offering, you probably don't want any of your tenants see exactly what node this is and what specification it has. We have a feature called pseudonodes, and that's a default on. And that essentially prevents that you're seeing the node spec. We are making up the node, if you will. So we're seeing the node name in your vCluster. So we see pod 2 and ended on node A, right? And then we just make up the node, right? That's what vCluster does. That's called pseudonodes. That's the default behavior. But if you're building something like an EKS, you may want to have your tenants actually see their nodes, and you want to have them see the node specification, and you want them to be able to run their own schedulers inside their virtual cluster, right? So you may have a default scheduler down here, but you want them to run their own Volcano scheduler, for example. And in order to do that, Volcano needs to see the nodes, right? So I got to make these nodes visible in the vCluster. And then that's where node syncing comes in. So if we're going back to the vCluster configuration, there are options regarding how the syncing mechanism happens between the physical and the virtual control plane. So we see two hosts, for example, how pods are being synced down is configurable. There's certain things I can do around them, right? Force tolerations, translate images. There's things like patches that I can do, where I can literally do JavaScript expressions to change certain things. In this case, the name of container. I'm not sure if that would make too much sense. Example here, but it's those kind of things you can do. It's very, very flexible. And if you go
internal
into
user, it's like an internal user asks for, like, I want a 100 node cluster. You're like, I'm gonna give the 100 node cluster. I can just like populate it with like fake nodes, and then here's your 100 node cluster.
Technically, you could, I guess. Yeah. So if you go into from host, that means I'm taking resources from the host cluster and I'm making them visible inside the vCluster. So we could do from host nodes, and by default we would have pseudo nodes, but we can enable this, and then we can say do everything, which means I'm selecting all the nodes. We have an example probably down here. Let's see. And then, oh yeah, there we go. Or I can say I'm selecting by label. And there you could say tenant 1, right? Or tenant is tenant 1. And all the nodes that are labeled like this would be visible inside your virtual cluster now. So we would turn this on to, I think we have it here. Yeah, enable true. And then we would say labels tenant is tenant 1. And that means all the nodes that have that label would be visible in my virtual cluster by default. So if these two nodes here are visible, then effectively my first tenant here would see, there we go. This is what my tenant would see. And now every time a pod gets created in this process here, in this what we call sync process, we would actually put a node selector on that pod and enforce it. So you don't even need mutating admission control. We do it automatically. That means your scheduler down here automatically only puts workloads for these two nodes because those two nodes are owned by your tenants. It still makes sense to have vNode running on each node, as I said, to essentially shield things from your own instrumentation running on that node, and to allow your tenants to run things like privileged containers and things like that. But keep in mind, if you have multiple of these tenants, right, or even you have this mode and this mode, this is still one Kubernetes cluster. So generally, there's network connectivity between these nodes. And maybe you don't even want that. Maybe you want your tenants to run completely autonomously and isolated from each other. They have their own CNI, right? The network is completely segregated, right? You can achieve this with network policies. You can segregate nodes with node selectors. But what about if I want to run different CNIs, different CNI versions, etc.? So let's take another virtual cluster here, vCluster 4. And this is something we have not shipped, but it's something that we're heavily working on right now. Spinning up this vCluster 4.
Spoilers.
Yeah, it's a little bit of a spoiler. Let's take two nodes here. And with these two nodes, what I'm actually doing is I'm not joining them into this cluster here, right? This is one big cluster, which runs all of my vCluster control planes. And they can run, maybe I'll draw a line in here, make that red. So this mode here would be called shared nodes. I'm literally able to share nodes, but I probably need to heavily restrict my tenants and what they can schedule on here, and definitely need to secure things on these nodes if they're running in shared node mode.
It's like a more secure general multi-tenancy where you don't care if they have their own nodes. They just want to have access and do Kubernetes things with GPUs.
Exactly. Yeah, it's more of a serverless Kubernetes offering that you probably want to launch for your tenants here. And then you have dedicated nodes. And in this one, we are essentially using a node selector to dedicate specific nodes by the node selector to our tenants. But what we can do with this here would essentially mean I'm joining nodes into this control plane. This is a Kubernetes control plane. And, probably if people are familiar with kubeadm, right, you could literally say, I'm going to take this node here and I'm going to join this node into this control plane. And I'm going to take this node here and I'm going to join it into this control plane. So now I have a control plane that runs in cluster A, but I have cluster B over here, which is actually my tenant cluster. And the beauty of this is it's completely separate. So this has its own network, right? It runs its own CNI. So this is entirely separate network from a Kubernetes perspective. Versus here, we would actually, if we have two tenants that look like this, they would technically run in the same CNI in the same network, and you'd have to work with network policies to isolate things. So this mode is currently not available in vCluster, but it will be available in just a couple of weeks from now. And that's very interesting because you can have an entire spectrum of multi-tenancy. You can go from complete serverless offering, something like ECS, to something that gives your tenants more autonomy and dedicated nodes, but without the complexity and overhead of managing an entirely separate cluster, to running dedicated clusters for tenants with what generally is referred to as hosted control plane approach, where the control plane runs inside a pod, but the nodes are separate, full-blown Kubernetes nodes.
And why does that matter, right? Because like vCluster brings up a pod, but if you don't want that pod running on your GPU node taking up space, you can have these all running somewhere else, right? Like, whereas the VM has to run on the node too, right? So
yeah, I mean, it's really a trade-off, right, between what can be shared and how isolated things are. So obviously here, you can drive up utilization of that node over here really high, because you can have one scheduler really efficiently pack these nodes with workloads, versus if you're forming separate clusters here, if this tenant is underutilizing these nodes, there's not much you can do. Maybe for GPU cloud providers, that matters less because your tenants are paying for these nodes, right? But one interesting thought is actually, so you can nest virtual clusters. So your tenants, they may buy a 20 node cluster from you. And if they're not getting the most out of these nodes and out of the utilization of these nodes, it gets harder for them to justify the ROI. So potentially they have the same, so you give them one cluster that has 10 nodes. Now they're running things like Run AI or Volcano or things like that in there. Now the problem they have is internally, they may have 10 different development teams that are working on training workloads, LLMs, etc. How do they split things up inside this virtual cluster? And one of the funny things about vCluster is you can nest them. So you as a GPU cloud provider could run this vCluster here with dedicated nodes, but inside your tenant could run a vCluster that's configured to run like this, because it's within their own boundaries, right? It's within their own company, versus you want to keep 2 different customers separate from each other. So vCluster can be stacked like that. But again, ultimately with the syncing mechanism, it's not like nested virtualization where every layer adds another kernel and you lose performance. It gets synced down to the next layer. So have, one layer of virtual cluster syncing to the next one. And then in this case, it would not sync. It would actually schedule directly on the nodes because there's no underlying cluster other than this vCluster itself. But you could technically have like 5 layers of vCluster inside each other. And the only thing that's a little bit slow is, or that's slower, is the creation of the pod, because you have to, reconcile the different pods across the different levels. So I wouldn't go too deep, but maybe 2 layers is something definitely possible.
But you're talking like seconds and stuff. You're not talking like, minutes. It's not going to be like a 20-minute thing. It's going to be like maybe
we're actually talking more milliseconds, to be honest. And it's only to launch the workload. The beauty is once the workload is running, it's native bare metal performance because it gets propagated down to the lowest cluster. And that cluster just schedules a pod and runs it with native performance. And maybe the only overhead additionally is you may wrap it around the vNode. And that vNode is also just a container. It's very, very lightweight, right? So the performance impact is close to 0 with the vCluster and vNode architecture.
All right, Lucas, we've had you for about 45 minutes now. I think we'll see if there's any other questions, and then we'll do some closing thoughts and stuff too. So if anyone has any questions on that, I'm going to drop back to this. If anyone has any questions, let us know. We're going to wrap it up, but we have more coming, right? Like we just wanted to get on here and brainstorm with everybody about like what we're thinking of as the future and like what you can do. We've seen a couple of use cases come up that are interesting that we're like, oh, we can help with that. And we weren't thinking about them before, right? Like the SQLite questions kind of made you start brainstorming like, oh, you're giving a vCluster to someone and they have 100 users on there, or they're running like all these workloads and they're using it for production. They're not just using it for ephemeral stuff like that. But do you have any closing thoughts or anything? Like what can people do next? Sign up for vNode, like mess around with vCluster. What would you recommend if you're looking to move from VMware?
Yeah, I mean, vNode is definitely an interesting project to check out. You can find it on vnode.com. There's actually a little demo video on the page as well. I highly encourage you to just check that out as a starting point. There's a comparison table on the side that compares the differences, between vNode and Kata containers and gVice and things like that. But there's also vcluster.com, and vCluster is even better because it's open source. You can get your hands dirty right away and just spin one up in Docker Desktop or Minikube or whatever you have running locally. But obviously you can also run it in EKS, GKE, your own GPU cloud that you're building, right? And explore vCluster. And if you're interested in going deeper and want like an architecture session, that's typically what we do when folks knock on our door. They say, hey, we want to build, our own Kubernetes managed offering. Here's what we're thinking. Here's the hardware that we have. Here's what we're planning to run on the network. And here's how vCluster could fit in. The first step for a lot of these cloud providers, but also generally, larger companies trying to do this for internal private clouds, is to have a conversation with us to talk about, does this architecture make sense? Can we try certain features and evaluate them? And we're really helpful and open in these kind of conversations to make sure folks build in the right direction, because it's always easier to fix things on the drawing board rather than fix it later after you already got started and you're like, dang, I wish we would have done it differently, right? So just reach out to us. We're pretty approachable. We got a Slack channel. Or Slack community. That's a great way to get in touch with all the engineers working on vCluster, but also with me and anybody else on the team.
Awesome. Well, thanks for your time. I had a good time. Hopefully people learned some stuff and saw some interesting things. And yeah, definitely reach out to us. Let us know what you're doing, because some of the stuff you're doing are things that we're not even thinking about, right? Like we can learn from you as well, right? Like we've learned a couple of things over the last couple of months that are making us reassess and do these new use cases and stuff. But thanks for your time, Lucas. You want to say bye or anything, or we'll see you next time?
Yeah, no, this was fun. And you're right? We find out new use cases every day. If you would have asked me, if you would have asked me in 2021, when we got started with vCluster, whether vCluster would be such an important building block for bare metal Kubernetes and for GPU-enabled Kubernetes clusters and GPU clouds, I wouldn't have thought of this at all. But here we are, and it's really exciting to play a role in these mega trends that are happening in our industry.
Awesome. We'll keep an eye on vCluster, and we got some more stuff coming up. Check out our YouTube channel and all that. And we have some more streams and some more webinars and different ideas about this. But thanks for your time. We'll see you next time. All right.